Welcome back to Maths with Mrs. J. We're talking about trigonometric identities. The first thing you need to understand is the difference between an identity and an equation. An identity is true for all values. Okay, so for all values of theta, sine squared theta plus cos squared theta will equal 1. These are also identities. They're really by, I guess you could say, by definition. We already knew that tan of theta is sine of theta divided by cos of theta. We already knew about cotan from when we were doing our vertical reference, and we said that cotan was the reciprocal of tan, so obviously it's cos of theta divided by sine of theta. These reciprocals are defined as follows. Sec of theta is the reciprocal of cos of theta, and cosec of theta is the reciprocal of sine of theta. Here are two other interesting identities. These come as a consequence of your rules of sine of alpha plus beta and cos of alpha plus beta when you just put alpha and beta both equal to theta. So sine of 2 theta is 2 times sine of theta cos of theta. Cos of 2 theta is cos squared theta minus sine squared theta. I am going to do some ones with those at a later stage, but I just want to sort of keep things relatively simple for now. Now, the first thing you need to understand about proving trig identities is that you cannot work with both sides at the same time. You cannot assume that they are equal and use that to prove that they're equal, because in doing that, you're actually proving nothing whatsoever. What you need to do is one of three things. You need to either start with your left-hand side and sort of try to manipulate that into what the right-hand side is, or you need to start with your right-hand side and simplify it, etc., into the form of your left-hand side. If you're really, really stuck with either of those, then you can do your left-hand side and get that down to equal something. And if you can get your right-hand side to equal the same thing, then obviously they must be equal each other. Okay, that's not the preferred way of doing it, but it's still acceptable. What is not acceptable is to be assuming the equal. So I can't start moving things over the other side or dividing everything by something. Now, normally what we're going to do, if a side is more complicated looking than the other side, that's usually the best side to start with because there's more stuff we can do to it. So let's have a look at the left-hand side here. So we're hoping to be able to fiddle around with this and get it into the form of cos of theta. Well, sec of theta is 1 on cos of theta. Tan of theta is sine of theta on cos of theta. And of course, this is just sine of theta. Won't do anything with that yet. So all over cos of theta, we have, what do we have? We have 1 minus sine squared. Now, our Pythagorean identity tells us that 1 minus sine squared is cos squared. And we're almost there. What's cos squared divided by cos? Well, it's just cos. So that's our right-hand side. By the way, just to remind you, when we say cos squared theta, what we mean is cos of theta and then square it. The reason why we don't write it after the theta is that then there could be confusion as to whether you're squaring the theta or whether you're squaring the whole thing. So that's why we put it there. Okay, so we've already done one trig identity proof. We're now ready to do some more. One really cool, I guess you could call it trick, is to multiply by a version of 1 that will help you. Now, we've used this trick before several times. One time was when we had something like a surd with an irrational denominator, something like, I don't know, square root 3 over, we might have had square root 3 over 2 minus root 2 or something like that. And what we did there to rationalise that denominator was we chose the version of 1 that is the conjugate surd. We also used conjugates when we were talking about complex numbers, okay, if we wanted to have a real number in the denominator. So that's a very handy process, and because of our Pythagorean identity, if we can ever get 1 minus sine squared theta or 1 minus cos squared theta, that can then progress pretty quickly to helping us finish our proof. Let's have a look at this one here. It doesn't really matter which side you start with. You certainly cannot just say, oh, well, cos phi times cos phi is 1 minus sine squared phi. Well, it's obvious that it is, but we've got to prove it. We've got to choose a side and try to knock that into the shape of the other side. I'd be inclined to actually start with my right-hand side here. And I'm going to use this sort of trick and multiply by 1 plus sine over 1 plus sine. For 2 reasons. One is I can use difference of 2 squares in the denominator to get 1 minus sine squared, which is cos squared. But secondly, I've noticed that this 1 plus sine is sitting there. So having that in our numerator is likely to be helpful. So I'm going to leave that in its brackets for now. No point in expanding because we're hoping to be able to cancel out anyway. Denominator, we're going to get 1 squared minus sine squared, which is 1 minus sine squared. As we were hoping for, this is cos squared. And this will cancel with one of those, and we're left with 1 plus sine of phi on cos of phi, which of course is our left-hand side. We're going to do a similar thing with this one. I'm actually going to show you how to do it both ways. You can, quite often with these, you can work from one side and get to the other, vice versa. It doesn't really matter. I'll just show you both ways here. So if we're going from our left-hand side, we're going to do like we did with this one over here. We're going to multiply by an appropriate version of 1 that will help us out. So we're going to end up with 1 minus cos squared beta in the denominator and sine of beta times 1 minus cos of beta in the numerator. Excuse me. Okay, so we get sine of beta, 1 minus cos of beta over, well, 1 minus cos squared is sine squared. The sines will cancel and we're left with 1 minus cos of beta over sine of beta. Now we're not there yet, but we're nearly there. Because they're both over the same denominator, I can now split this up into 1 over sine of beta minus cos of beta on sine of beta. 1 on sine is cosec and cos on sine is cot. So we've got our right-hand side. Let's see if we can go back the other way. So let's start with the right-hand side. Okay, well, cosec is 1 on sine. Cot is cos on sine. So we're going to get 1 minus cos on sine. Now, in this case, I'm going to want to work to use a difference of 2 squares in my numerator. So I'm actually going to multiply by 1 plus cos over 1 plus cos. In our numerator, we're going to get 1 minus cos squared. In our denominator, we're going to get our sine of beta, 1 plus cos of beta. This, of course, is sine squared. And of course, the sines cancel and you're left with sine over 1 plus cos, which of course is your left-hand side. So multiplying by an appropriate version of 1 can be very, very helpful, and just bear that in mind. It can save you a lot of trouble. All right, let's go on to some more. Okay, these ones are a little bit more tricky, but that's okay. Let's have a look at the first one. What side do we want to work with? We're probably better off working with the left-hand side to start with. There's probably more we can do with a sum or difference than with a product. So let's do that. Let's start with our left-hand side. So we've got cot squared theta minus cos squared theta. Well, what is cot squared? Cot squared is cos squared on sine squared. All right, how about we pop the whole thing over the same denominator? So we're going to get all over sine squared. Well, obviously that's just cos squared. And this one we're going to get cos squared sine squared. We've multiplied the denominator, which was 1, by sine squared, so we need to multiply the numerator. Okay, what are we going to get? Well, we're going to get in our numerator, we can take out a cos squared as a common factor. We probably could have done that to start with, but that's okay. So we're going to get 1 minus sine squared over sine squared. What's this? 1 minus sine squared is cos squared. So we're going to get cos squared theta and then another cos squared theta over our sine squared theta. Now, why did I write it like that? Because I'm trying to wrap it up in a bow to look exactly like our right-hand side. There's your cos squared and there's your cot squared. So we've got cos squared theta times cot squared theta, which is our right-hand side. Okay, last one for this video anyway. You need to remember this before you can do this one. If you've got the sum or difference of 2 cubes, it factorizes in this way. I haven't done a lot on sum or difference of 2 cubes, but I have mentioned this before when we were doing, I think it was de Moivre's theorem proof it came up in. So this is like our A, our sine of alpha is like our A, and our cosec of alpha is like our B. I'm going to definitely want to start with that left-hand side because it's more complicated. So our left-hand side is sine cubed alpha plus cosec cubed alpha over your sine alpha plus cosec alpha. Okay, A cubed plus B cubed. So it's A plus B, A squared minus AB plus B squared. All right, that's your A squared minus AB plus B squared. We're going to do all over our sine plus cosec. Now we're lucky here in that we can do some cancellation. Obviously that whole bracketed expression can be cancelled out. All right, so we just need to work with this bit here now. Let's see what we're going to get. So we're going to get sine squared minus sine times cosec. Well, sine times 1 on sine. Well, the sines are going to cancel, aren't they? Plus cosec squared is 1 on sine squared. Actually, I'm going to leave that as a cosec squared because that's what we're looking for there anyway, isn't it? I'm going to leave it there because that's what we're wanting. So plus cosec squared. Because we've already got that part of it. So what's this? This is sine squared alpha minus 1 plus our cosec squared, which is what we're hoping for. This here is negative 1 minus sine squared. If you want to change the order of a difference, multiply it by negative 1 and swap the order. So this here is your cos squared. So this is your minus cos squared plus your cosec squared And you can then reorder those to do cosec squared minus cos squared, which of course is our right-hand side. And there you have it.